This is one of the harder exponential equations that I assigned for homework, so I thought I'd sit down and explain it to you a little bit and see if it makes more sense to you. E to the x minus 12, e to the negative x minus 1 equals 0. So what I thought I'd do is substitute. I think that's the easiest way to do this problem. So I set out by letting y equal e to the negative x. And if y equals e to the negative x, therefore 1 over y would equal e to the x. So I would substitute y in for the places that I said x would be. And so that gives me a new equation. 1 over y minus 12y minus 1 equals 0. Now this is an equation that should be familiar to you. We studied these equations in the first half of the course. It's a rational equation. So I'm going to multiply both sides of this equation by the least common denominator, which is y. And that gives me a quadratic that looks like this. I don't like dealing with a quadratic like this, especially with a negative lead term. So rearranging the terms and multiplying both sides by -1, I get a quadratic that looks like this. I then factor that if I can. In this case, this one can be factored. So that gets to be factored to be 4y minus 1. Oh, 3y plus 1. Solving for y, I get y to be 1 over 4, or negative 1 over 3. And if you remember what I said y was e to the negative x. Therefore, 1 over y is equal to e to the x. I'd much rather solve for e to the x. So since y is equal to this, 1 over y is equal to 4. So I go back and substitute and get, since we're solving for x, since y is equal to 1 over 4, 1 over y equals 4, e to the x, therefore equals 4. Now I'm going to solve these two equations. In solving these equations, e to the x equals 4, therefore x equals the natural log of 4. And when I look at e to the x equaling -3, there is no value for which x can be negative. This expression approaches 0, never gets to 0, so therefore it can never be negative. And therefore we're done. If they ask you to approximate it to the nearest 4 decimal places, this is the answer. And so I'd like to circle that. And we're finished with this problem. See if it makes sense to you, and practice some of the other odd ones in the book.